Hello. In this video we're going to extend our work on the sine and cosine and area rules for non-right angled triangles. Okay, we looked at the general rules in a previous video, but now we're going to look at a special case. I sometimes call this the ambiguous case, where you will see why in a few moments. So we're given a description here of a triangle ABC. We're told that the angle at A is 40 and there's a line joining the points A and C of length 10 and B and C of length 7. Well, before I go any further and even look at the questions, I'm going to sketch what this will roughly look like. Okay, so we're going to start with a line that's going to be the base of our triangle. I'm going to call this the line AC, okay, and I'm going to make it 10 centimeters long, and from the point A, which I'm going to use this point on the left, I'm going to make an angle of about 40 degrees, okay, and I'm deliberately extending that line up there, AB, because I don't know how long that line has got to be, okay, so it's roughly 40 degrees. I would say is probably about there. Now, it doesn't have to be to scale, but I'm doing it as best I can to help you understand what's going on here. So what I'm saying is that this length, this point here is the point A. So therefore, this angle here is the angle A. Okay, this point is the point C, and we're told that the length of AC is 10. Okay. Now, of course, we could have had this line as AC being 10 and then this other line coming down underneath it. It wouldn't have mattered because it's all relative to the position of A. So let's now try and put the point B. Now, we're told that B to C is 7 centimeters long. Well, if this line is 10, we're going to try and create a line of 7 centimeters and from C. Now, if I start at C, the line AC is 10. I would estimate that that green line I've drawn is about 7 centimeters. So it's going to hit the red line about there. Okay, so let's put that there. Now, if I were to put a compass point there and set it to 7 and swing the compass round, you would see that it would actually also come to this point about here. In other words, this blue line I'm going to draw now could also be 7 centimeters in length, but meeting the line A at a different point B, okay? Because that blue line is about 7 centimeters as well, if it's supposed to be the same as the green line. So what I've done is I've shown that based on this information, there are two possible triangles that could be created. The larger one, ABC, or the smaller one, ABC. Both have a line of 7 centimeters opposite the angle A. Both have a line of 10 centimeters joining the points AC. So I'm just going to call these 2 points that I've created B1 and B2, okay, because there are 2 possibilities here. So let's call this one B1 and this one B2. And by labeling the points B1 and B2 like this for convenience, I'm going to refer to this angle as B2 and this angle as B1, okay? Now, the first question says calculate the largest possible angle B. Well, if you look at these 2 angles I've just drawn, B1 is larger because it's an obtuse angle, B2 is smaller. So I'm interested in working out B1. Now, this is what I need to do. I'm going to start by using the sine rule. And the sine rule will tell me that, and this, by the way, at A, I should mark this angle is 40 degrees. Okay, so I better put that in first. And also, before I go any further, I ought to label these 2 lines as 7 each. Okay, right, so using the sine rule, I know that sine b over 10 equals sine 40 over 7. Okay, so I'm going to just write that down. I'm just going to use b at the moment because you won't know which one of the b's we are finding doing this just yet. So I'm going to put sine b over 10 is equal to sine 40 over 7. Okay, I'm just going to put the fraction lines in like this, and this is question A I'm doing at the moment, so I'll just label that there. Now, if you follow that through, you simply multiply both sides by 10, and that will give you that the sine of B, okay, is equal to 10 times the sine of 40 degrees, make sure the calculator is in degrees, divided by 7. Okay, so that's how we use the sine rule to rearrange it to find whatever is unknown. So our unknown is sine of B. Now remember, the sine of an angle is between -1 and 1. Okay, so if we put that on the calculator, it comes to, and I'm going to use several decimal places here, and it's okay to do this as long as you go well beyond the number of decimal places required in answers. So they're wanting 3 significant figures ultimately. So for the moment, this is 0.918268. 918268. Okay, and then it goes on. I've got another 3 decimal places here, 014. Okay, so that's more than enough accuracy at the moment. And of course, you could store that in the memory of your calculator, which might be quite a useful thing to do while you're working on the problem. Now, that's the sine of the angle. That's not the actual angle. Now, if I put inverse sine of that, okay, it gives me that the angle B, so I'm putting in the calculator shift sine of that number, okay, or shift sine answer, and it's giving me 66.674 degrees. Okay, 66.674 degrees to 5 significant figures, or 3 decimal places. Okay, now if you look at the diagram, it has given me the angle B2. Okay, you can see that that's less than 90 degrees, and it's the smaller angle, and that will always give you the closest angle to 0, the first angle that has a sine of that number. Now, to understand what's going on here, I'm going to bring in the graph of sine, okay, because this is really important that you understand this. So I'm going to put this in here and just leave it down there, I think. And I'm going to show you how this works now. If I can just make that a bit smaller that way. Okay, now what we've done here is, if I put a horizontal line on this graph, okay, maybe in a different color, you can see that the sine was 0.918. So this is 0.8, 0.6, 0.8, 0.9, 0.918. It's about here. Okay, it's just above 0.9. And you can see that it crosses the sine graph at 2 places. The first place it crosses here is what we got from our calculator, 66.67. Okay, so that point there gave us the smaller angle, which was 66. I'll just put 66.674. Okay, now this one over here is bigger, and that one there is actually the same as 180 minus this. Okay, and you can tell that just by looking at the symmetry of the graph. So if I just put a vertical line down the middle of this graph through 90 degrees, okay, that's a line of symmetry. And this, the amount this is from 0, that's 66.67, is the same distance as this one is from 180. So where I've put that second arrow, it's actually equal to 180 minus 66.674, and that comes to 113.326. Okay, 113.326, and that's rounded to 3 decimal places as well. Okay, so that number there is actually the angle B1. So the largest angle, because it says calculate the largest possible angle B, so that's what B is, which is B1 in fact. So I can now say that B2, so it implies that B2, that's the larger angle, sorry, B1 rather, that's B2, that's the smaller angle, that B1 is actually 180 minus 66.674, and as I've just worked it out and written it over here, 113.326, and I'm writing it in full for the moment, or more accurately than I need, ... which is equal to 113. It wants it to 3 significant figures, so it's 113 degrees to 3 significant figures. Okay, so I'm showing how I got that answer, but then I'm rounding it suitably as requested. Okay, so that's how I would answer that question, part A. Now in part B, it says calculate the largest possible area of the triangle ABC. Now, it's quite easy to see what's going on here. You see, if I went from A to B1 to C, that's going to create that area in there, which is quite small. To get the largest area, I would have to go from A to B2 to C. So it would be the bigger triangle of the two. And the bigger triangle uses the smaller angle, B2. All right, so what I'm going to do to find the area is to use the rule, area is a half AB sine C, okay? So I need two sides that are next to each other that I know, okay, 10 and 7, and I need the angle between those two sides. And the angle between those two sides is this one here. All right, now I'm going to highlight this by shading it in yellow, okay, because it's the whole of that angle that I'm calling C. All right, now that angle C is going to be made of 180 minus 40 minus B2. So this angle C that I'm going to use in this question, that's angle C, okay, angle C, is going to equal 180, which is the angles in a triangle, take away 40, okay, and it's going to be taking away the smaller angle that I had for B2. Now the smaller angle is the 66.674. Okay, and that gives me that the angle I've shaded in yellow, C, if you put that on the calculator, as 73.326. okay, to 3 decimal places. 73.326 degrees. Okay, now it looks about right on the scale that I've drawn here. Okay, and that's what it is. So using that angle, I can say that the area, right, the area equals 1/2 times 10 times 7 times the sine of the angle between them. Okay, and the sine of the angle between them is 73.326. Okay, so we have to now put that into the calculator to see what that comes to. And it comes to 0.5 times 70, which is 35, times the sine of the angle I've just given, which is 73.326, to 5 significant figures, and that comes to 33.528. Okay, 33.528, so it's 33.5 centimeters squared, okay, to 3 significant figures, which is what I was required to give. Okay, so that's the second question done. And just at that point, it might be worth looking at that triangle and saying, well, look, I've got a triangle here that has it's, if I sort of tipped it on this side here, that's 7 and that's 10, so that makes you think around 70, and the area of a triangle is half of that, so it's about 35, so it's pretty close, so it looks about right in the context of this diagram. Okay, now we go on to the third question. And that's an unusual looking question when you first look at it, because it's saying, show that AB must be either the longest or the shortest side of the triangle ABC. And basically, this is another way of saying that the line AB can either be less than 7 or greater than 10. That, if you think about it, that's what it means, doesn't it? So basically, I've got to find the 2 possible lengths of A and B. The 2 possible lengths of the line AB. So it's either this short bit from A to B1, or it's the longer bit from A to B2. And I'm expecting one of those to be less than 7 and the other one to be greater than 10. Okay, in order to answer that question. So let's do the short one first. So I'm going to call this length here. Now we've got to be careful with our notation here. So if I first of all work out the short length, all right, that's from here to here. Okay, I'm going to call that length there C1. Okay, C1. So that's a lowercase c, and it's C1. Okay, now to find that length, I've got to use the smaller angle in here. All right, so I'm going to have to show this by just removing some of that yellow. Okay, because I'm going to use again the sine rule. Okay, I could do this using the cosine rule, and it works perfectly well if you do, but it's actually easier to use the sine rule if you can. So what I know now is that C1 over the sine of this angle is the same as 7 over the sine of 40. All right, but what's this angle in here that I've now shaded in yellow? Well, that angle comes from 180 minus 40 minus this larger angle here, which was 130. So if I call this angle in here C1 with a capital C, That's angle C1, right? This is why it gets a bit confusing when you're using lower and uppercase C. But angle C1, right, is equal to 180 minus 40 minus 113.326. And that's going to be a smaller angle, and that comes to about 20, well, not about, it comes to 26.674. 26.674. Okay, so the length C1, this is lowercase c, C1 over the sine of that number I've just written down, okay, the sine of the smaller angles, 26.674, is equal to the 7 over the sine of 40. Now notice that this time, because the unknowns are lengths, I'm using the sine rule upside down. Here we use sine 40 over 7 and sine b over 10. Here we're using the length over the sine of the angle and the length over the sine of the angle, which is often what we do with the sine rule. It's easier to have the unknowns on the top of the triangle, the fraction. Right, okay, so if we rearrange that, that gives us that C1, so basically I'm going to do 7 times the sine of that divided by the sine of 40, and it gives me that C1 is 4.88. In fact, it goes 4.888, okay, which is equal to 4.89 to 3 significant figures. And I'm putting centimeters to make it clear that it's a length we've just found. Okay. Now, that is less than 7 and less than 10, so that's the shortest possible length of the line AB. And the other angle, the other line is C2, and C2 would be the longest possible length. And I'm going to do that in a different colour. Let's see if that colour there would work. So I'm now suggesting that we find, this is not the best colour, let me just undo that and try something a bit lighter, possibly this one here. Okay, it's not much better, but this time I'm finding the length C2, which is that orange line, okay, the longer length. So C2, this is the side length C2. Okay, I'm going to run out of space in a minute. C2 over the sine of the other possibility, which was the larger angle, which we've already worked out as 73.326. Okay, so C2 over sine of 73.326. Okay, that is equal to the same thing as we've just had, which is 7 over sine 40. Okay. Now, if we just rearrange that in the same way by multiplying both sides by sine of 73.326, we get that C2, that's length C2, okay, so this length here, right, that's the whole of that orangey coloured line is of length C2, okay. What we're saying is that that comes to 10.432, okay. 10.432 if you work that out. Okay, 10.432, which is equal to 10.4 to 3 significant figures, centimetres, to 3 SF. So what we've done is we've shown that that is greater than 10, okay, which is also greater than 7. In other words, we've shown that it's either the greatest length of that triangle, or in this case, I just need to say here that 4.89, I'll just put this as a separate statement. It's a bit squashed here, but I think you've got the idea. I'll just take this out the way. Okay, so I can also say as a separate statement that from here, 4.89 is less than 7, which is less than 10. In other words, I'm showing that in that case, C1 is the shortest possible length of the side. So we just about got there. Quite a lot to do on that question, but that's how I would present my answers. And I hope in all that clutter and explaining you can understand what's going on. Made slightly complicated by the fact that I had to use lowercase c and uppercase c, and it's not always clear whether I was talking about an angle or a side, but you should be able to work through the video and see which is which. Okay, so these are referring to side lengths here. Okay, and those are referring to angles. And by the way, just to finish off, that of course could be written as C2 because it was the larger angle at C, which was the whole of that. All right. Okay, I hope that was helpful and has taught you about a very important concept that you have to be aware of with dealing with these sorts of problems, the ambiguous case. Thank you for watching.